Today we're going to review radical operations. If you can remember, a radical has a value under the square root sign, and we call this value the radicand. The radicand. That's the value under the radical symbol. And sometimes we have a value in front, and that's going to be the coefficient. But what we're going to focus on first is simplifying the radicand. And what we do is we separate the perfect part from the non-perfect part. So the first thing you do is you're going to put down two square root symbols. And what I want to do is think about the factors of 27. I want the largest perfect square. That's a factor of 27. And that would be 9. And then 9 times 3 would be the 27. Then what you do, you're going to take the square root of the perfect square, and you're going to leave the other radicand under the radical sign. So the square root of 9 is 3, and your final answer is going to be 3 radical 3. So let's look at one that has a coefficient in front. Here we have a coefficient of 3 and a radicand of 48. The process is going to be the same. You're going to put down two radical signs, but the coefficient is going to stay in front until the end. Now, the largest perfect square that goes into 48, that is a factor of 48, is 16. And 16 times 3 is going to get you that 48. Then you take the square root of 16, because 16 is a perfect square. So I still have my coefficient of 3. The square root of 16 is 4, and you have your radical 3. Then what you do is you multiply the coefficients together. So my final answer is 12 radical 3. That's how you simplify a radical. Now, if you want to multiply radicals, the process that we do is we multiply coefficients by coefficients and radicands by radicands. And then you simplify. So we multiply first and then simplify. So here's what we do with this guy. My coefficients are both 1 here, so that will be, it's an implied 1. And then the 2 times the 6 is 12. Once I get there, I need to simplify, which was the process I just talked about previously. So to simplify, I've got to put down my two radical symbols. The largest perfect square, that is a factor of 12, is 4. So I break the 12 up into a 4 and a 3. I take the square root of 4, and I end up with 2 radical 3. So we multiply and then we simplify. So now we're going to do an example with coefficients as well, because when we do this, we're going to multiply coefficient by coefficient. So the 3 times the 2 is going to be a 6. And then I'm going to multiply radicand by radicand. So I have my square root symbol, and the 5 times the 10 is going to be 50. From there, we want to simplify. So we multiply first, and then we simplify. My 6 is a coefficient. He stays out in front. The largest perfect square that is a factor of 50 is 25. 25 times 2. And then I take the square root of 25. I leave my radical 2. And I multiply the coefficients. So the final answer is 30 radical 2. If I'm going to divide radicals, I still divide the coefficients and I divide the radicands. So they are 2. We keep them separate. So if I'm going to divide, I have 4 divided by 2 on my coefficients. Gives me a 2. And then under the radical symbol, 24 divided by 2 is 12. Once you divide, you still have to simplify. We always simplify our radicals down to the lowest term. So we always kind of factor out the perfect square part. So we put down our two parentheses. 12 is broken up into a 4 and a 3. And please remember, it's not 6 and 2. because I have to have a perfect square under my first radical sign. And then taking the square root of 4 is 2, and I end up with 8 radical 3. Now here's a division problem that looks slightly different. I have a fraction as a radicand. What you do there, that's equivalent to breaking it up and placing the numerator as a radical and the denominator as a radical. In this case, the numerator is a perfect square, so I can take the square root of 100 and get a whole number. That's going to be 10. But my denominator is not a perfect square. What we have to do in this case is we have to rationalize, because we don't like to have irrational values in our denominators. To rationalize it, I'm going to multiply numerator and denominator by radical 7. And what that does is my numerator is now 10 radical 7. The denominator, when I multiply a radicand by itself, or radical by itself, the answer is the radicand. So radical 7 times radical 7 is 7. And you end up with 10 radical 7 over 7. Finally, we're going to add and subtract. Now the process for adding and subtracting radicals is a little bit different. You have to have like radicands. You treat the radicands like variables. You have to have like radicands in order to combine them, and then all you do is you add or subtract coefficients, and we leave the radicands alone. Okay, so in this case I have 3 radical 2 minus 7 radical 2. That's the same as 3 minus 7 times radical 2, which gives you negative 4 radical 2. I could only do that because they both had a radical 2. So in this final example, I have 2 radical 3, and I want to add to that 2 radical 27. We never add radicands. What I have to do is I have to simplify first. I simplify, and then I add the coefficients of like radicands. So 2 radical 3 is as simplified as it's going to get. So he stays 2 radical 3. And then for radical 27, I do the standard process. The largest perfect square that goes into 27 is 9. So that's 9 times 3. So I have 2 radical 3 plus 2. The square root of 9 is 3. And that's times radical 3. 2 radical 3 plus 6 radical 3. Now my radicands are identical. That's equivalent, or that's like adding 2x plus 6x. We add the coefficients only, and we get 8 radical 3. So that's a quick review of all the radical operations that we're going to practice more during class.